Hi guys, welcome and let's solve this question. And the question reads, evaluate the integral. We have integral from 0 to 1 over dx over x squared plus 2x plus 5. And so guys, now we come to do the question. The first thing guys we are going to do, we are going to complete the square for this denominator term. And so therefore we shall have x squared plus 2x plus 5. This now comes to completing the square. You shall have the square root of x squared, which is x, now plus half of 2 is 1. We square that, now minus 1 squared, which is the same as 1. And from that we can now add 5. And therefore, guys, our equation then is going to be x plus 1 squared, now minus plus 4, like that. And therefore, guys, this equation right here can be represented as integral from 0 to 1 of dx. And now, guys, we write our transformed denominator, which is x plus 1 squared plus 4. From there, we can come and say let, we replace for x plus 1, let x plus 1 be equal to u. And therefore, we shall have du all over dx. Guys, this comes now to 1. And therefore, we can say that du is equals to dx. And at the same time, we can come and now replace our lower limit and the upper limit. And for that, we say u equals to x plus 1. And therefore, if we put x equals to 0 for the lower limit, this now will come to when we are now with respect, integrate with respect to u. Guys, this now comes to 1. That is when you place 0 here. Pressing x equals to 1, guys, now this comes to 2. And so for our integral, whereby we are going to integrate with respect to u, our limits are going to be 1 and 2. And therefore, guys, now I can write that. And this is how I write it. I have integral from now 1 to 2. The upper limit is 2. And then instead of now dx, we write now du. We replace dx with du all over. We have x plus 1 squared. We can replace now with u squared. And then plus 4. So guys, this is our new integral. And with that, guys, we can look at the integral, that is integral for this term. Guys, now from our tables, that is mathematical tables, we have this integral, whereby integral of du over u squared plus a squared is equals to 1 over a tan inverse u over a plus c. And so guys, you can see this is in the same form as that. Guys, we just need to come now and modify this. And this is how we modified it. We write from 1 to 2 integral du all over u squared, of which the u squared we still have it as here, plus a squared. For a squared, Guys, we can write 2 and then we square. Remember, this now comes to 4 as it is. And so therefore, this is what now we come and integrate. And guys, we are going to have our integral as 1 all over a is 2 in this case, tan inverse, and u is now going to be, you can just write u all over a. Guys, since this is a definite integral, we don't put a c, this c, and therefore we can now come and put our limits. That is from 1 to 2. This now comes to a half, and then we have the upper limit is 2, that is tan inverse 2 all over 2, which is 1, minus tan inverse 1 over 2. So guys, that's what we have. And then now, when we come here, guys, this is going to be a half. Tan inverse of 1 is pi over 4. Actually, that is 45. Now minus. Guys, we can even leave it like this. Tan inverse. We can put 0.5 like that. And so guys, this is our solution. Guys, even if you leave it like that, it's quite okay. But you can actually work out and get the real answer. And so guys, thank you for listening to me. Bye bye.